All right, so chemistry, paper 2, 2017. Question 1. A pupil was performing a titration experiment in a science laboratory. Accidentally, the reagent bottle containing sodium hydroxide fell onto the floor and broke, thereby spilling the sodium hydroxide solution on the floor. State with a reason one precaution the pupil needed to take when cleaning the spillage. Now, remember, you've broken something that contains sodium hydroxide. Now you want to clean. So state one precaution that you need to take when cleaning. What should you do when cleaning the spillage that contains sodium hydroxide? From what you think?
Sodium hydroxide ni acid kan?
No, this is a base. It's not an acid.
Sila ko H2O ba?
Use English. Mm.
The people must wear safety gloves.
Why? So when you're handling sodium hydroxide, this is a base just like acids. This is harmful. So when dealing with this, make sure that you wear the same soft gloves to protect yourself from the harm. Because when this thing comes in contact with your eyes, your skin, you can even lose your hair. Okay, like you can lose your hair on your skin because it's very harmful. So you need to make sure that you wear those. State two other safety rules that are supposed to be observed in a science laboratory. What rules do you know that is supposed to be done in a lab? Apart from you wearing gloves, what other rules do you know?
Follow instructions.
Okay, every time follow instructions by the teacher. Uh-huh. Apart from that,
Must avoid loose clothes.
loose clothes, don't eat anything in the lab. Okay, don't touch things with bare hands. Wear soft safety boots, safety goggles, all those uh, rules. Okay, let's look at this. The diagram below shows the heating cave for pure substance. The temperature rises with time as the substance is heated. So what we mean by heating cave? Heating. So let's say when you start heating something, okay, let's say you have got ice. When you heat ice, you give it heat. What is it going to change to?
Liquids.
Liquid what?
Liquid form.
Liquid water. Okay, because ice is water, isn't it? Liquid ice. That means solid ice. And then when you continue heating the liquid, what are you going to have?
Gas.
Okay, gas, which is a vapor, isn't it? So the change of ice to liquid, what do we call it?
Melting.
Melting, good. And then the change of liquid to vapor,
Evaporation.
evaporation. What's the other name? Vaporization. Vaporization. So if we have got arrows going in this direction, when going down, remember we were heating. So meaning when going up, we are cooling. So if you want to draw that cave, you call it a cooling cave. It looks something like that. It's just the opposite, cooling cave. And then this one we have is a heating cave. So the change of vapor to liquid, what do we call it?
Condensation.
Condensation. And then the change of liquid to ice?
Freezing.
Okay, freezing. What of the direct relationship from ice to vapor or from vapor to ice? What do you call that? What do you call that? Okay, it is called sublimation. Are you able to get me?
Yes.
Okay. So we have said the direct change is called sublimation. So we can answer the questions. So before we even answer the questions, we can label this diagram. Those are some things that you're able to do when you're in an exam. And before you answer the questions, you can just look at the diagram you've been given. Okay, so remember this is a heating curve. Heating. So what will be A? Is it going to be a solid or a liquid or a gas?
Solid.
So it's A is a solid, and then C is what?
Movement.
Liquid. Here we don't have a gas. What of B? What will be here? Is it a solid or a liquid at B?
Solid.
So at B you have got a mixture. There is a change of state happening. Huh? So you have got a mixture of solid and liquid, and then since this is gas on top, at D you have got a mixture of liquid and gas. So B, this process is melting, and then D is vaporization of evaporation. What physical state or states is a substance in at A and C? Okay, so we have said that A is solid, at C is liquid. Describe the movement of particles of the substance at A and C. What are the movement of particles in a solid and in a liquid?
In a solid, they are closely packed together.
Okay,
They vibrate.
particles only vibrate. So that's what they want. Movement, eh? Okay, particles vibrate. So we want the movement, not the arrangement of particles. We want the movement of particles. What of in a liquid? How is the movement?
Freely.
Okay, particles are able to slide over each other. So they are able to move sliding past each other like that. Okay, what is the melting point and boiling point of the substance? Let's look at the diagram. From the diagram, can you deduce what would be the melting point? The melting point is a point when the solid is changing into a liquid. What would be the melting point? So the melting point is where you see the line is straight. So the melting point is 60 degrees, and then boiling point is this one here. Also at the line where it is straight, that is 120. So at the melting point and boiling point, temperature does not change. Temperature is constant. So describe what happens to the temperature while the substance is changing its state. I have already said, right? Temperature is constant, or temperature does not change. Does not change. That is why you saw at the melting point it was just 60, boiling point it was just 120. There was no change in temperature. Is that okay? Are we good? Okay, so we have got now this one. The diagram below shows the experiment arrangement for carrying out fractional distillation. This is fractional distillation. And remember, we already learned fractional distillation. So even before we answer, we can deduce what do we call B? Do you remember the name of B? Okay, so B is the Liebig condenser. And then because this is distillation, what is going to drop into the beaker after distillation is called distillate. If it was filtration, you call it a filtrate. And then A, this is the fractionating column, which contains what is inside the, those are called glass beads. Fractionating column. Now, what are some of the things that we separate using fractional distillation? Separate alcohol and water. So this process is used for two miscible liquids, liquids which are able to mix completely. So name A and B, we have said A is the fractionating column, B is the Liebig condenser. We should not just say condenser, but Liebig condenser. Name the general name given to C, that is the distillate. And then C, what type of mixtures are separated by this process? So fractional distillation, we've said the miscible liquids are the liquids that you separate, liquids which mix completely. So liquids which are immiscible, those which do not mix completely, you use separation funnel. So you left the class, but we have moved. So you follow what you've missed using the class record. Good. What change would you make to the above diagram if you were to separate water from salt solution? So if you want to separate water from salt, then what you use is simple distillation. So you simply remove the thermometer and the fractionating column. That's what you remove. And then connect the Liebig condenser direct to the volumetric flask. Okay, we are now on question 4. Using dot and cross diagrams, show the structures of the following compounds. We have magnesium oxide. What is the symbol of magnesium? What's the symbol of magnesium?
Mg.
Okay, capital M, small g. And then oxygen is capital O. Now you want to use a dot and cross diagram. Okay. So when you are drawing these, you need to make sure that you write a key. A key is very important. So for the key, I'm going to say, I'll just write here key. For magnesium, I'm going to use a cross. Then for oxygen, I'm going to use a dot. All right. So you have got magnesium coming together with oxygen. Now you need to know that oxygen always exists with a 2 down. So every time you are reacting magnesium and oxygen, you should always have a 2 down, and that should produce magnesium oxide. Now when you form a compound, forget about this 2 which is down here. Okay, when you form a compound, forget about the 2. Just know that oxygen always exists with that 2. Now oxygen, what is the valence of magnesium? Sorry, just a moment. Okay, so this is what I was talking about. So what's the valence of magnesium? It has a valence of 2. Very good. What of oxygen? What is the valence?
2.
2. Good. So meaning if I swap, the valence for oxygen is supposed to go on magnesium here. The valence for magnesium is supposed to go on oxygen here. But since it's the same number, it will be able to cancel out. So therefore, the symbol for magnesium oxide is just MgO, right? MgO. Now, magnesium is a metal. Oxygen is a non-metal, meaning that this type of reaction is going to be, what type of bonding is this? Is it ionic or covalent between a metal and a non-metal?
covalent.
Good. It is not a covalent but ionic. Metal and non-metal is ionic. Covalent is between non-metals. So I'm going to get magnesium. This one they've told us we only show outer shells. We only show outer shells. But one thing that you need to know is you need to know the electron configuration for magnesium and also for oxygen. Let me check on the periodic table if it was given. Okay, here is the periodic table. Magnesium has got proton number of 12, oxygen a proton number of 8. Okay, take note of that, 12 and 8, so that now we use that. Okay, we'll come here. So magnesium, remember it has got 12 electrons. So the electron configuration is going to be 2. What will be the next? 2 comma what?
8.
Comma. Very good. What of oxygen? What will be the electron configuration? It has got only 8. 2 comma 2,6. Good. So what I'm going to do is I'm going to write magnesium. I'll put Mg, okay, with a 0 like that. This one we are only interested in outer shells. So the electrons in the outermost shell are only to remember for magnesium we are using uh, X. So I'll put it like that. And the electron configuration, don't forget 2 comma 8 comma 2. And this is reacting with oxygen. The outer shell has got 6 electrons, and this one we're using a dot. Okay, so we only have 6. And what are we going to form? So now for an ionic compound, what you form, you are going to put them in. So I'm going to write like this. You put them in square brackets. So what is going to happen is magnesium is going to lose these 2 electrons that you're able to see in the outermost shell. So it is going to lose these 2 electrons. So the outermost shell is going to remain with 8 electrons. Those are the ones who are going to show 1, 2, 3, 4, 5, 6, 7, 8. Okay. The electron configuration, don't forget it, of the new magnesium. Now it is an ion because it has lost. It is now 2,8. Don't forget that. And then oxygen, those 2 electrons which magnesium has lost will be gained by this 6. So there will now be 8 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. Remember you have gained the 2, so show with an X because those are coming from magnesium. And then the electronic configuration is now 2, comma 8. So oxygen, because it has gained electrons, it will have a charge of negative 2. And then magnesium, because it has lost, it is going to have a charge of positive 2. So this is how you get to write the compound that is formed. Is this okay?
Yes.
Okay, we want also to write carbon dioxide. What is the symbol for carbon dioxide?
CO2.
Uh-huh. Okay, CO2, very good. So meaning we have got 1 carbon with 2 oxygens. Now for this one, what is this, a covalent bond or an ionic bond?
This one covalent.
It's covalent because all of them are non-metals, right? So now for a covalent bond, you need to show the overlapping of shells. So actually, we just need to know that this one looks like this. It has got double bonds. That is how it looks. Okay. So what I'm going to do is I'm going to put carbon on the middle. Now carbon, let's consider the electron configuration for carbon. Carbon has got 6 electrons. So what will be the electron configuration?
2,4.
2,4. And then oxygen has got 8. The electron configuration is what?
2,6.
2,6. Good. So I'm going to have one like this. I'm going to have another one like this. Then I'm going to have another one like this. Okay, the one which is on the middle is carbon. And then the ones at the end, they are the two oxygens. Now remember, each oxygen has got 6 electrons in the outermost shell. So again, we need to write the key. The key is always very important when you are answering these questions. So for oxygen, I'm going to use a cross. Then for carbon, I'm going to use a dot. So oxygen, remember, it has got each has got 6 electrons. So first, the first two, I'm going to put it them here. 1, 2. Okay, 3, 4, 5, 6. And then also in this other one, 1, 2, 3, 4, 5, 6. So for oxygen, I've already written. And then carbon, each one, I mean, carbon has got uh, 4 electrons, right, in the outermost shell. So I'm going to put one here, another one here, and then one here, another one here. So this is a double bond. Also, this is a double bond. This is what we're able to see. Now, for this one, they've told us to show all shells. So meaning for, let me also show for those which are inside. Carbon has got 2 electrons inside. Remember, carbon we are using dots. Same with oxygen. It is 2 comma, it has got also 2 inside like that. Also this oxygen has got, oh sorry, for oxygen we are using a cross. Even this one is like that. So this is the bond, this is the carbon dioxide. Is that okay?
Yes. So utakuwa ukipenda wapi connected.
Yeah, just that. State any two differences in physical properties between ionic, which is also called electrovalent, and covalent compounds. So ionic compounds, one thing we should know. Okay, maybe you have got any characteristic that you know before I mentioned. Any difference between ionic and covalent compounds? Okay, ionic compounds, you can think of sodium chloride, which is salt. Okay, and then covalent, think of water. What's the difference between water and salt? What you are able to see?
Water, solid.
Okay. Mhm.
What difference is
So physically, mostly uh, ionic substances are solids, crystalline solids. Okay, mostly. What I mean by crystalline is like they form crystals. Crystals, the way salt is, those are called crystals. But right, you can talk about their melting point. Those are physical properties. Sodium, I mean ionic compounds dissolve. They have got a higher melting point than these covalent compounds, because ionic bonds seem to be much stronger than covalent bonds in these compounds. Okay, so ionic compounds have got a higher melting point and boiling point than covalent compounds. Another thing, we talk about the way they conduct electricity. Ionic compounds can conduct electricity in molten state. What do we mean by molten state? You need to heat. So like the way salt is. Okay, I'll give an example of candle. Candle, if you heat it, it will melt. So that is in that state you call it molten state or melted state. So ionic compounds conduct electricity in molten state. Wow. Covalent compounds mostly they don't conduct electricity. Is that okay?
Yes.
So those are some characteristics that we are able to give. Okay, we can consider question 5 as the last question. An organic compound containing 40% carbon, 6.6% hydrogen, and the rest oxygen. Now, if you've been given that 40% is carbon, 6.67% is hydrogen, and then the rest is oxygen, how can we find the percentage of oxygen? How can we find? Uh-huh.
Subtract carbon and nitrogen
Mhm.
from 100%.
Okay, good. So it will be 100 minus 40 minus 6.67. And that is going to give us 53.53. I mean 53.33. So we'll say element, that's the first thing you write, okay? You write element, write them in order. The first one given is carbon, followed by hydrogen, and then oxygen. And then you look at their percentage composition, which is also percentage mass. So for carbon, it is 40. For hydrogen, it is 6.67. Oxygen is 53.33. The next thing that you find is the moles. How do you find moles? More number of moles is given by mass over molar mass. Okay, so we're going to say 40 divided by the molar mass for carbon is 12. And then also 6.67 divided by the molar mass for hydrogen is 1. And then 53.33 divided by the molar mass of oxygen is 16. So we start 40 divided by 12. This has given us about 3.33. 6.67 over 1 is approximately equal to just 6.67. 53.33 divided by 16 is approximately equal to 3.33. The next thing you need to find is called the mole ratio. So the mole ratio, you look at the smallest number between these, amongst these. So which one is the smallest? Which?
We were 3
Oh, good.
3.33.
So these are the smallest. So to find the mole ratio, divide everything by 3.33. So it will be 3.33 over 3.33, and then 6.67 over 3.33, and then 3.33 over 3.33. So this will give us a 1. This will give us approximately a 2. Please make sure that you round off, you get a whole number, but this one will just give us a 2, and then this will give us a 1. Therefore you can now write the empirical formula EF, empirical formula. So you've seen carbon, it has got a 1. You put this one that you have found, and then hydrogen, you have found a 2, so put a 2 down here. And then oxygen, you have found a 1, so just write like this. So the empirical formula is CH2O. Is that okay?
Yes.
And then you've been told, remember, the mass of zero point 0.2 moles of the compound is 3.6. The mass of zero point 0.2 moles of this compound. So you have been given the number of moles as 0.02 moles. And then you've been given the mass as 3.60 grams. Okay. So the next question, they are saying find the molecular formula of the compound. Now to find the molecular formula, the first thing that we need to find is N. How do you find N? N is molecular formula mass divided by empirical formula mass. That is how you find N. Molecular formula mass divided by empirical formula mass. Now where do you get the molecular formula mass? You've been given the molecular formula mass. Okay, you've been given this mass as a that was a 36 or 3.6. That is 3.6. You've already been given the mass, so that is 3.6. And then what of the empirical formula? So the empirical formula mass, what you do is first find the number of moles from the empirical formula. Remember the empirical formula is CH2O. So oxygen, you know the molar mass is 16. We have got one hydrogen and the molar mass is 2. Then you have got one carbon, the molar mass is 12. So if you get to add this, 12 plus 2 plus 16, that is going to give us 30.
40.
Not a 30.
Yeah, good.
Okay, it's a 30. So we find now the mass. Mass, how do you find mass when you know the number of moles and molar mass?
Um, Make m simple to the formula.
Okay, so mass is number of moles times the molar mass. So the number of moles we've been given already in the question as 0.02. The molar mass is 30. So multiply 30 multiplied by 0.02. That is going to give us 0.6 grams. So this is the one you divide 0.6. Okay, so you have got 3.6 divided by 0.6, and the answer is 6. So molecular formula is given by empirical formula and then with N down here. So the empirical formula is CH2O and then N we have found 6. So the molecular formula is going to be C6H12O6. That is going